7.2a, we are simplifying complex fractions. What a complex fraction is that you have a fraction over another fraction. Our goal, if you look back here, is that you want to simplify your numerator and your denominator so that they're a single term or a single fraction. And then what this really is like a fraction divided by a fraction. So that's where you're going to do your same, change, flip, or keep, flip, change, your KFC. And then you'll simplify. So it's basically just building on what we've done. It's just written in a different way. So if we start with our numerator is already simplified. It's x over 5. Okay, we don't have to do anything on that. But on our denominator, it's not a single term. We need to simplify this. So with our denominator, we have x over 5 plus x squared. And I'm going to put x squared over 1 because in order to add fractions, they need to have common denominators. So our common denominator on this would be 5. So that means I just have to multiply this term by 5 to the top and the bottom. So when I do that, actually I'm going to go down here. We have x over 5 plus, and I'll have 5x squared over 5. Now I can't add x squared and x together. So that means when I write this out, I have it as 5x squared plus x over 5. And if you can end up factoring this, you want to. And we can, okay? So we can take out our GCF of x. So I have 5x plus 1 over 5. So my numerator is simplified, and now my denominator is simplified. So if we write it how they have it in the problem, and I'm just going to kind of separate this a little bit, you have it as x over 5 divided by x times 5x plus 1 all over 5. Another way to look at this, which I think makes sense, more sense, is that you have it as, I'm just going to make another line here. This is x over 5 divided by x times 5x plus 1 over 5. So we've learned that in order to deal with fractions and division, you have to change it to multiplication. So we're going to end up changing this to x over 5 times, because remember KFC, keep, and then we change to multiplication, and then we flip this one. So it's going to be 5 over x times 5x plus 1. And then we reduce if we can. And hopefully you notice that these x's right here, since they're by themselves, they can cancel, and the 5's can cancel. And so nothing is left on top, so that means we just have a 1 on top, and then on the bottom I'm just left with 5x plus 1. And that is your answer. All right, example 2. So this one, our numerator and denominator are going to have to be simplified. So I'm going to start with my numerator. I have x over 3 minus 6, and 6 can be written as a fraction by putting it over 1. Then I need to get a common denominator in order to add them together. So my common denominator is going to be 3, which means I'd have to multiply the top and the bottom here by 3. So I still have x on the top here, and then 3 times 1 made 3, and 6 times 3 is 18. So now we just end up with x minus 18 all over 3. And so I can't factor anything, so this is my numerator simplified. Now I go to my denominator. So my denominator, I have 10 plus 4 over x, and I'm going to change 10 to a fraction by putting it over 1. Now on this, my common denominator would be x. Okay, this one doesn't change, so it's 4. I'd have to multiply 1 times x in order to make it x. And 10 times x makes 10x. So now I can add those together, and I have 10x plus 4 all over x. And always check if you can factor. Here I could take out a GCF, which is 2, and I'm left with 5x plus 2, and this is all over x. So my denominator has been simplified. Okay, now if we write this, this is x minus 18 over 3 divided by 2 times 5x plus 2 all over x. But we don't want it to be division, so we have to do our same change flip, KFC. So we get x minus 18 over 3 times, and we flip this fraction and get x, and then 2 parentheses 5x plus 2. If you look through here, nothing can simplify. So that's it. We just have to kind of put everything together as a single term. So we end up getting, since x is by itself, I bring that to the front, and then I have x minus 18. And then on the bottom, I have 2 and 3 that are by themselves, so you multiply that together and get 6, and then you have 5x plus 2. And that is your answer. And you can always double check if you can reduce, but again, looking here, nothing will reduce. Moving on to example 3. So same thing on this, just like we did on the other problems. I'm going to take my numerator. My numerator, I have it as 1 plus 1 over y. I'll change this 1 to have a denominator of 1. In order to get common denominators, my common denominator will need to be y on this. Since this one already is y, I just keep that 1 on top. On this one, I'd have to multiply by y to the top and the bottom. So 1 times y is y. When we add that together, I get y plus 1 over y. My numerator is simplified. Now I go to my denominator. I have x plus x over y. And I'll change x right now to have a denominator of 1. So between 1 and y, my common denominator would be y. So I rewrite this. X stays on the top there. In order to make this a y, I'd have to multiply by y to the top and the bottom. X times y is xy. You always write them in alphabetical order. And then when we combine them together, I can't add an xy and x together because they're different, but I can write that as x plus xy all over x. And then hopefully you'll see you have a GCF there of x. So I'm going to factor out an x, and then I have, when I factor out an x, I divide by x to both of these, and you end up with 1 plus y. And then this is all over x. So we have our numerator and we have our denominator. So if we write this out, it's really y plus 1 over y divided by x times 1 plus y over x. But we can't divide fractions, and so we have to do our KFC, same change flip. Y plus 1 over y, change division to multiplication, and flip this. So we get x over, and then you have x and then 1 plus y. So you can simplify here, and maybe you even notice back there, but we can cancel out these x's. Y plus 1 and 1 plus y, we know those are the same because the y's are positive and the 1's are positive on both of them. So I can cancel out each of those. If nothing's on top, that means we are just left with a 1, and then there's a y on the bottom. So my answer is 1 over y. Okay, moving on to example 4. Same thing again. Numerator. You have x plus 1 over 6. Our common denominator would be 6 on this one, and we put this one over 1. Since this is already 6, I go ahead and rewrite my 1. Here I'd have to multiply by 6 in order to get a denominator of 6, and so we get 6x. So now I can add, and I get 6x plus 1 all over 6, and that's my numerator. It will not factor any further. For my denominator, I have x squared minus 1 over 36, and I'm going to change x squared to have a denominator of 1. Between these two, my common denominator would be 36. This is already 36, so I keep the 1 there. Here I'd have to multiply 36 to both the top and the bottom. So I end up with 36x squared over 36. When I simplify that, I get 36x squared minus 1 over 36. And you always want to check if you can factor. Hopefully you notice that 36 is the same thing as 6 squared. And 1 is the same thing as 1 squared. And so if you notice, all of those are squares, which means it's a difference of squares. So that factors to be 6x minus 1 and 6x plus 1, because those are all squares. And this is all over 36. I couldn't reduce 36 back there because it has the minus 1. Anytime it has something connected with the minus or a plus, you can't cancel it unless it is exactly the same. Okay, so I have my denominator answer. So again, if we write this out, I have 6x plus 1 divided by 6 divided by 6x minus 1 times 6x plus 1 all over 36. But we cannot divide fractions, so we change it to multiplication. 6x plus 1 over 6 times, we flip this to be 36 over 6x minus 1, 6x plus 1. And now we check if we can reduce. Hopefully you notice 6x plus 1 and a 6x plus 1 can cancel. And then 6 can go into 36 6 times. So my answer ends up being 6 over 6x minus 1. And again, I can't cancel those because there's that minus sign, and everything has to be exactly the same in order to cancel those. So that's your final answer. And that is the end of 7.2a notes.